Have you ever gazed up at the night sky and felt a sense of wonder? The vast expanse above us is filled with countless mysteries and breathtaking sights. On a clear night, far from city lights, where the sky is unpolluted by artificial light, you might see a faint fuzzy patch. This small, indistinct blur is not just a cloud or a trick of the eye. This isn't a cloud, but a vast island of stars, the Andromeda Galaxy. It's a colossal collection of celestial bodies, first recorded in 964 AD by the Persian astronomer Abd al-Rahman al-Sufi. Andromeda was simply a smudge of light. Early astronomers could only speculate about its true nature. Centuries passed before astronomers, armed with telescopes, grasped its true nature. These early telescopes were rudimentary, but they opened up a new world of discovery. Andromeda, also known as M31, is a spiral galaxy much like our own Milky Way. Its structure is a beautiful, swirling pattern of stars and cosmic material. It's a gigantic collection of stars, gas, dust, and planets, all bound together by gravity. This gravitational force keeps the galaxy intact and functioning as a cohesive unit. Imagine our sun as just one grain of sand on a vast beach. The sheer number of stars in Andromeda is staggering. Andromeda contains 1 trillion of these grains, making it significantly larger than the Milky Way. Its size and scale are almost beyond human comprehension. This majestic spiral, with its arms swirling outwards, is a testament to the immense forces at play in our universe. These arms are regions of active star formation and cosmic activity. Andromeda sits about 2.5 million light years away from us. This distance is so vast that it challenges our understanding of space and time. That means the light we see from it today began its journey long before humans even walked the Earth. This light has travelled across the cosmos for millions of years. Looking at Andromeda is like peering back in time, observing a galaxy as it was millions of years ago. It's a window into the distant past of our universe. It's a humbling reminder of the vastness of space and the ancient history of our universe. The Andromeda Galaxy stands as a beacon of the incredible scale and age of the cosmos, inspiring awe and curiosity in all who observe it. Our galaxy, the Milky Way, isn't alone in the vast expanse of space. It's part of a group of galaxies called the Local Group, and Andromeda is the largest member. Think of the Local Group as a cosmic neighbourhood with galaxies as houses scattered across vast distances. Andromeda and the Milky Way are the two largest houses on the block, engaged in a gravitational dance over billions of years. Gravity, the force that holds us to the Earth, also governs the interactions of galaxies. Andromeda and the Milky Way are drawn to each other by this invisible force, slowly being pulled closer together. It's like a slow-motion waltz, with each galaxy moving under the influence of the other's gravity. But it's not just a two-way dance. The Local Group is also home to dozens of smaller galaxies, each with its own gravitational pull. These dwarf galaxies add their own subtle steps to the cosmic ballet, influencing the movements of both Andromeda and the Milky Way. The dance between Andromeda and the Milky Way isn't a peaceful waltz. It's a cosmic ballet with a dramatic finale. It's leading to a dramatic collision, a spectacle of unimaginable scale and beauty. This celestial event has been billions of years in the making, a slow-motion drama unfolding in the vastness of space. Astronomers, using the Hubble Space Telescope, have measured Andromeda's movement with remarkable precision, tracking its every move. Their observations confirm that a head-on collision is inevitable, a cosmic certainty written in the stars. Mark your cosmic calendars. The big event is predicted to occur in about 4 billion years, a date set in the distant future. That's a long time, even by astronomical standards, a span that dwarfs human history. But it's a blink of an eye compared to the age of the universe itself, which is about 13.8 billion years old, a testament to the vastness of cosmic time. The collision won't be a sudden impact, but rather a slow, drawn-out process, a gradual merging of two colossal entities. Over millions of years, the two galaxies will pass through each other, their gravitational forces distorting their shapes in a cosmic dance. As the galaxies merge, the space between stars, despite appearances, is so vast that actual star collisions will be rare, a testament to the emptiness of space. However, the gravitational interactions will send stars on wild new trajectories, reshaping the night sky as we know it, creating a new celestial landscape for future astronomers to marvel at. Galaxy collisions might sound catastrophic, but they're actually a natural part of the universe's evolution. Galaxies are constantly interacting, sometimes merging, sometimes tearing each other apart. These interactions are essential for galaxy growth and the formation of new stars. When galaxies collide, the gas and dust within them get compressed and heated. Think of it like clapping your hands together. The energy from the impact creates heat and sound. In the case of galaxies, this compression triggers a burst of star formation. New stars ignite from the swirling chaos, lighting up the merging galaxies with brilliant, young starlight. While individual stars are unlikely to collide, the supermassive black holes at the centers of galaxies are destined for a more dramatic encounter. These cosmic behemoths, millions or even billions of times the mass of our sun, will spiral towards each other, eventually merging in a cataclysmic event. In the grand scheme of the Andromeda Milky Way collision, our solar system is but a speck, a tiny dot in the vast expanse of the universe. But that doesn't mean we're immune to the effects. The gravitational forces at play will have profound impacts on the structure and dynamics of our galaxy. As the two galaxies merge, our sun, along with its planets, will likely be flung out to a new region of the combined galaxy, potentially altering the orbits of planets and other celestial bodies. It's like being on a carousel that suddenly changes speed and direction, a cosmic dance that reshapes the very fabric of our galactic neighbourhood. The good news is that our solar system is unlikely to be destroyed. Despite the chaos, it will remain largely intact. The distances between stars are so vast that even during a galactic collision, direct impacts are incredibly rare. Stars will pass by each other, avoiding catastrophic collisions. However, the night sky will be transformed. The familiar constellations we see today will be rearranged, creating a new celestial map. The combined glow of the merging galaxies will create a spectacular, ever-changing celestial display, a cosmic light show that will be visible for millennia. While the collision will undoubtedly be a significant event in the history of our galaxy, it's important to remember the timescales involved. This is not an overnight event. The process will unfold over billions of years, giving life on Earth, if any still exists, plenty of time to adapt to the changing cosmic environment. The slow dance of galaxies is a reminder of the immense timescales that govern the universe. The merger of Andromeda and the Milky Way won't be a quick, clean affair. It'll be a messy, drawn-out process, with the two galaxies first passing through each other, then swinging back around for a final embrace. This cosmic dance will trigger waves of star formation as the gas and dust within the galaxies collide and compress. Imagine vast clouds of hydrogen, the raw material for stars, being squeezed together by the immense gravity of the merging galaxies. This compression ignites nuclear fusion, the process that powers stars, giving birth to millions of new suns. These newborn stars will shine brightly, illuminating the merging galaxies with a youthful glow. Meanwhile, deep within the hearts of the merging galaxies, a more dramatic encounter will be unfolding. The supermassive black holes at the centers of Andromeda and the Milky Way will be drawn together by their mutual gravity. As they spiral closer, they'll warp the fabric of space-time, sending out gravitational waves that ripple across the universe. The collision between Andromeda and the Milky Way isn't just a random event. It's a fundamental part of how galaxies evolve and grow over billions of years. Think of it as cosmic recycling, where smaller galaxies merge to form larger ones, their gas and dust providing the raw material for new generations of stars. In fact, our own Milky Way has likely experienced numerous mergers throughout its long history. Astronomers have found evidence of past collisions in the form of streams of stars orbiting our galaxy's outskirts, remnants of smaller galaxies devoured long ago. These mergers aren't just destructive events. They're crucial for enriching galaxies with the elements necessary for life. When stars explode as supernovae, they scatter heavy elements like carbon, oxygen, and iron into space. These elements become incorporated into new stars and planets, providing the building blocks for life as we know it. Section 8. A new galactic home. Milkdromeda emerges. As Andromeda and the Milky Way merge, they'll create a new, larger galaxy. Astronomers have dubbed this future giant Milkdromeda, a fitting name for the union of our two galactic homes. Milkdromeda will be an elliptical galaxy, a more rounded and less structured type of galaxy than either the Milky Way or Andromeda. The spiral arms that characterize both merging galaxies will gradually disappear as their stars are scattered into new orbits. The central bulge of Milkdromeda will be dominated by a supermassive black hole, formed from the merger of the two original black holes. This cosmic behemoth will feast on surrounding gas and dust, releasing tremendous energy in the process. From our vantage point on Earth, or whatever remains of it, the night sky will be transformed. Instead of the familiar band of the Milky Way, we'll see a vast, elliptical glow encompassing the heavens, a testament to the power of gravity and the ceaseless dance of galaxies. Section 9. Time and Tide. Witnessing the unfolding cosmos. The impending collision between Andromeda and the Milky Way is a powerful reminder of the vast scales of time and space that govern our universe. Events on a cosmic scale unfold over billions of years, dwarfed by the age of the universe itself. Imagine trying to comprehend a billion years. It's 1,000 times longer than the entire history of human civilization. Yet in the grand scheme of the universe, a billion years is but a chapter in an ongoing story. We are fortunate to live in a time when we can observe and study these cosmic events. With advanced telescopes and sophisticated computer simulations, we can piece together the history of our galaxy and predict its future. We are witnesses to the unfolding cosmos, a privilege granted to a species that has only existed for a fraction of the universe's lifespan. Section 10. The expanding universe. Beyond the collision. While Andromeda and the Milky Way are destined to collide, it's important to remember that the universe is also expanding. The space between galaxies is stretching, carrying them further apart over time. This expansion is a fundamental property of the universe, discovered in the early 20th century. However, the expansion of the universe won't prevent the Andromeda-Milky Way collision. The gravitational pull between these two galaxies is strong enough to overcome the expansion of space, at least on a local scale. The expansion of the universe does have implications for the long-term future of Milkdromeda. As the universe continues to expand, the galaxies outside our local group will be pushed further and further away. Eventually, Milkdromeda will become an isolated island of stars, its light unable to reach us due to the ever-increasing distances. Section 11. Our place in the cosmic tapestry. The impending collision between Andromeda and the Milky Way underscores our place in the grand cosmic tapestry. We are part of a universe that is constantly evolving, where galaxies are born, collide, and merge over billions of years. Our own existence, fleeting on a cosmic scale, is a product of this ongoing cosmic dance. The elements that make up our bodies, the air we breathe, and the Earth itself were forged in the hearts of stars that lived and died long ago. By studying the universe and its evolution, we gain a deeper understanding of our own origins and our place in the cosmos. We are connected to the universe in ways we are only beginning to comprehend, our fates intertwined with the movements of stars and galaxies. Section 12. The enduring mystery unraveling the universe. The impending collision between Andromeda and the Milky Way is just one of many mysteries that continue to fascinate and inspire astronomers. While we have learned a great deal about the universe, countless questions remain unanswered. What is dark matter, the invisible substance that makes up the majority of the universe's mass? What is dark energy, the mysterious force driving the accelerating expansion of the universe? How did the universe begin, and what is its ultimate fate? These are just a few of the questions that drive our exploration of the cosmos. The universe is a vast and complex place, full of wonders yet to be discovered. As we continue to explore, we can be sure that new discoveries will challenge our understanding and inspire us to keep searching for answers.